I love math. Do you? Well, if you do, you should live by the math commandment that states, Thou shalt do unto one side of the equation what thou doest to the other.
Hey guys, let's go over D1, solving each system of equations algebraically, then verify each solution graphically. Okay, so how do we solve systems algebraically? The easiest method that you're going to see, and then if you look at both of those equations, they both are equal to what? The y variable. So this easiest, just use the substitution. What is substitution? I'm going to write the problem below. I have, I'm going to write it in reverse order. Y equals 2x and y equals x squared minus 6x plus 7. Okay, so what I'm going to do, I'm using my highlighter. If you have a highlighter, it's super helpful. Okay. Every time we see y, we're going to write 2x. Every time we see y, we're going to write what? 2x. So let's write 2x. So instead of writing y, we're going to write 2x. And everything else is the same. Okay, so now, so the first thing we did, let's just write that. We did a substitution. We did that in a blue highlight. Okay, next what we're going to do is we're going to solve. And in order to solve quadratics, we're going to have to set equal to 0. Set equal to 0. Okay, let's do that. If you want, you could just put a nice straight line. That was straight, right? And right down the middle of the equal sign. So I'm going to subtract 2x and put it with like terms. All right, so that equals 0 equals x squared minus 8x plus 7. Okay. Now in our last couple lessons, we learned what's the easiest way to solve quadratics. Well, I'm always going to shoot for the home run factor. So let's try factor. A times c and the b value. So a times c is 7. My b value is negative 8. I need two numbers that multiply to be positive 7. And I'm thinking of negative 1 and negative 7. Because you multiply those, it equals positive 7. You add them together, equal negative 8. Okay, what does that mean for us? 0 equals x minus 1, x minus 7. Congratulations, you just factored. Okay, now to solve, here I'm just using the zero product rule. And what that means is, remember my little analogy is square times triangle equals 0, which basically implies that the square has to be 0 or the triangle has to be 0. So you set them equal to 0, okay? You see this kind of splitting aspects. They're going to do the same thing here. Let's set it equal to 0 here. So I have x minus 1 equals 0 and x minus 7 equals 0. Again, you don't need those parentheses because you don't have any math operations on the outside there, so I would just add 1, and we're going to get x equals 1. And over here, we have x equals 7. Okay, what does this mean for us? Let me highlight those. Okay, so I'm kind of doing steps over here on the side, right? So my next step here is to sub x to get y. We want a y value, okay? And let's see if I can use my highlighter. This equation, I'm just going to use here. Let's go ahead and use that together. So I got y, that's a y, equals 2x. And you're going to do this twice. Y equals 2 times 1. And if you want to repeat it, you could just do it with x equals 7. Y equals 2x. Y equals 2 times 7. And then if you do that, you're going to get y equals 2 here. So when x is 1, y is 2. Okay, that's an order pair. Let's write that. Order pair. Okay? And we wanted to finish the one over here, so I get y equals 14. So my order pair is when x is 7, y is 14. Okay, what does that mean? That means we have two solutions. So let's go ahead and graph it now because they told us to graph it. It's going to be kind of not fun, but just because I don't have a ruler. And I'm going to 1 and 7, so I'm going to kind of cheat it a bit. All right, let's go ahead and graph. Let's call this one orange, okay? So remember that is in slope-intercept form. Y equals mx plus b. This is a 0, so my y-intercept is going to be a 0. And it has an m value, which means that this is 2 over 1, a rise of 2 and a run of 1, okay? So that means basically up to right 1. So let's go ahead and graph this. Up to right 1, okay? There's my point. Up to, rise of 2, run of 1. Do it all day long as you feel comfortable, and that's our orange graph. Do my best. Okay? So that was the one in orange here. Okay, let's graph this one over here. Let's use a different color. Let's use blue. Okay, so how do you graph that one? Well, if you think about it, go back to our quadratic that you already solved. This is going to have, sorry, take that back. If you factor this one, 8 times c is 7, b value is -6. All right, so if you go back and now graph y equals x squared minus 6x plus 7, you'll realize that you can't factor that. Two numbers that multiply to be 7, but also add to be -6. And there are two numbers, so that means it's prime, which means you can't factor it. But you can find the x-intercepts by using the quadratic formula. So I have the quadratic formula here below, and then the main point is that you're just finding those x-intercepts. I have 3 plus or minus radical 2. And if you graph y equals 2x, the blue and then the purple parabola, they intersect at those 2 points that we just found, 1, 2, and 7, 14. Hey guys, let's go over D2. Solve each system of equations algebraically, then verify each solution graphically. So we're going to solve the systems by substitution. How did I know by substitution? You'll notice that both those equations, the quadratic with the power of 2 and 1 to the first power, are both equal to y. So let me go ahead and write down those problems below, and we can work on this. So I have y equals x squared minus 3x plus 1. And I have y equals x minus 3. Just section on our work over here. Okay, so what can we do? We said we're going to solve these by substitution, okay? So I'm going to use my highlighter. If you have a highlighter, super helpful. Every time we see y, we can write x minus 3. I see y here, and so instead of writing y, we can write what? X, try it again, x minus 3. On the right side, everything just stays the same. So we just did substitution there. And I'm going to use the steps from the previous problem. We can now solve the quadratics. How do you solve the quadratics? We're basically going to move everything on the left side to the right. Why? Because we're trying to get it set equal to 0. Okay, so let me draw a straight line down the middle. If I can do that. That kind of shows the left and right side, right? So let's do the opposites, the inverses. So opposite of positive x is a negative x, that goes right there, and opposite of negative 3 is a positive 3, goes right there. Kind of just doing 2 steps in one. So this equals 0, that equals 0. We are left with x squared minus 4x plus 4. And again, we're trying to solve this quadratic. So the best way of solving is by using factoring. So let's see if we can factor this. Super happy, right? A times C is 4. My B value is negative 4. My two numbers that multiply to be positive 4, but have to add to be negative would be negative 2 and negative 2. Alright, so that gives us 0 equals x minus 2 and x minus 2. Okay? Then our next step is use something called the ZPR, which just basically says square times the triangle over on the left side equals 0, which implies that one of those has to be 0. So I'm going to set both of these here equal to 0. Now, it sounds kind of weird, but you have the same problem. So why would you do the same problem twice? They call this a double loop, and you'll kind of see why what happens. So if I add 2 here, x equals 2, and you have x equals 2. Kind of weird, right? Why would you have it twice? Now, next step is to sub x to get a y. So let's go ahead and substitute in x into a y. What am I going to use? Let's use our highlighter over here, and I already have up here y equals x minus 3. So I'm going to substitute in x equals 2 into this equation right there. Okay, let's do that. So I have y equals the 2 that we saw from below, the x value, minus 3. And this will give us y equals negative 1. So that step we said down here is in number 5. It's an order pair. Okay, so let's put those together. The order pair is 2, negative 1. 2, negative 1. Now, if you did it twice, you'll get the same order pair, which basically means they're going to intersect at one place. They're going to intersect at one place. Now, I didn't show this in the last problem, but if in the new problem here, if you do something called the discriminant, and it's greater than 0, you will have 2 solutions. Okay? If it is equal to 0, you will have 1 solution. And if you have it a number smaller than 0, negative, you're going to have 0 real solutions, if you think about it. Okay? So the reason why this works, let's do it on ours. Again, I'm using that one right here. So my b value, let's write down the formula. And our b value from above is negative 4 squared, and it's 4 times 1 times 4. So I have 16 minus 16, which equals 0. And that means there's only, because it's equal to 0, there's only 1 solution, which we have right here, 2, negative 1. Okay? Let's make that super obvious. Is that green? I like green. There it is. Okay? Now let's verify that graphically, okay? So there's my y, there's my x. Let's graph the linear. You'll notice that this is in the form of y equals mx plus b. So my b value is negative 3, so let's go ahead and find that. Let's up a little bit. Negative 1, negative 2, negative 3. Okay. And the slope here is 1, which means it is 1 over 1, which means a rise of 1 and a run of 1. What does that mean? Up 1, right 1. That's how you graph slope of linear equations. Let's do it together. Up 1, right 1. Boom. Up 1, right 1. You can do that all day long. Here, I'll do something crazy. Ready? Left 1, down 1. That's negative 1 over negative 1. It's still positive 1. Is that crazy? Alright, so let's see. This is our graph in orange. Let's do our best. There it is. Okay, now let's graph the quadratic. do a little math on it. Okay, so this one's a little bit tricky because if you do the factoring, you'll get 1 and then b value -3, and there's no values, which means it's not factorable. Okay, what does that tell us? I do know one point. Let's go to this one point over here. 2, -1. We already know that we have something at 2, -1. So let's write that 2, -1. I already know my answer is going to be there. Write 2, -1. There is my solution. But how does my graph go through there? So this is in standard form. ax squared plus bx plus c. And we have a y-intercept of 1. There's my y-intercept. Okay. The a value is positive, so positive people smile. So it's going to graph up. Okay. So we need to go through there and go through it once. And we pick a color. Let's do blue. Okay, so let's graph that. How does it go through once? Because then maybe those orange will never, and the blue won't intersect. But the big idea here is that the intersection is right here. That is the order pair 2, -1. So this problem you have one solution. Okay? See you guys. Hey math lovers, let's go over number 3. Again, we're solving this systems and then we're going to graph it to verify our answer. Okay? So let me write this problem down below so we have some more space. I have y equals -x minus 2 and y equals 2x squared plus 16x plus 24. So we said we're going to use this, we're going to solve it by substitution. And the reason why I'm using substitution is because they're both equal to y. So use your highlighter. Every time I see y, we're going to write -x minus 2. I see y, and instead of writing y, we're going to write -x minus 2. -x minus 2. And I have 2x squared plus 16x plus 24. Okay? Alright, let's set this equal to 0 now. So I'm going to draw a line down the equal sign. Some space to work. So I'm going to move this -x to the other side. So to do that, I'm going to add the opposite. And line them up with like terms. So I have 0 equals 2x squared plus 17x plus 26. Okay, let's see if we can solve this by factoring. And remember, a value is 2 here, so I'm going to have to use both the x in the box if the x puzzle works. Let's go ahead and try that. A times c is 52, and my b value is 17. Let's list all the factors of 52. Remember, this visual might help you. 4 goes in 52 once, and 13. And any others? Can't think of any. Which one of those works? 13 and 4. 13 times 4 gives us 52, and 13 plus 4 gives us 17. So those are the two numbers, 13x and 4x. I'm going to take those values from over there, 2x squared and the 26. We're trying to solve this, and the easiest way is by factoring. So let's go ahead and solve this. GCF this way gives me a 2x. GCF this way gives me an x. Going this direction, I have a 2, and this direction I have a 13. So let's just double check that that works. 2x times x gives me 2x squared. 13 times x gives me 13x. 13 times 2 gives me 26. And 2x times 2 gives me 4x. So that works. Let's go ahead and write that over here. So over here in green on the outsides, on the right, x plus 2 and 2x plus 13. Again, the order does not matter once you write them. So what we're trying to do is just solve for x here. Let's go ahead and do that. I'm going to set each of those equal to 0 and go ahead and solve those. I get x equals a negative 2, and over here I'm going to subtract 13. 2x equals negative 13, and divide by 2. You're going to get x equals negative 13 over 2, or 2 goes into 13, negative 6.5 times, right? Okay, what are we doing after this? We have your x values, and you actually have two solutions. And again, you could have tested that by the discriminant. You didn't need to, but b squared minus 4ac. If it's greater than 0, you have two solutions. Equals 0, you have 1. Or it's less than 0, you have 0 solutions. Okay. So let's go ahead and get a y value. And the easiest way to get a y value is using this linear equation, because it's the easiest to work with. So let's go ahead and bring it down here. Pencil's working. There we go. Y equals negative x minus 2. Y equals negative x minus 2. And let's do the orange one. So negative 2. And let's work with fractions. Fun fractions. Negative 13 halves. Alright, so over here I have y, one color. Y equals negative minus 2. So opposite of negative 2 gives me 2 minus 2 is, that would equal 0. So the order pair I have from up here is negative 2, 0. Let's do this one over here in green. I have y equals the opposite of that, minus. Can't really do that. Sorry. There you go. Okay, so let's just simplify the. This is a positive 13 halves minus 2. Okay. How do you make 2 a fraction? Just put it over 1. I need a common denominator, meaning that the bottoms have to be the same. So I can multiply by 2 over 2, and this gives me an equivalent fraction. Let's do that. Y equals 13 halves minus 4 over 2. And I'm just going to subtract the numerators. 13 minus 4 will give me a y equals 9 halves, or 4.5. So from above, that means my order pair is negative 6.5, comma 4.5. So you can do fractions and decimals, is up to you. I think decimals make more sense because it gives us some numbers. Okay, let's put those on our graph. Let's go up here. And the orange one was negative 2, 0. So I already know my graphs are going to intersect there. And the green one, negative 6.5, 4.5. Negative 6.5. 1, 2, 3, 4, 5, 6. Negative 6 and 4.5. So somewhere around here, okay? Alright, let's graph these now. Remember that's in slope-intercept form, so there is my y-intercept. Negative 2. And it has a negative slope, so that's a negative 1. So this would be down 1, run to the right 1. So from here, down 1, right 1. Down 1, right 1. You can do it as many times as you want, and you'll get this point here. Okay, so that's my graph in blue. Let's go ahead and graph that. Okay, this one, they're all evens. I'm going to factor a 2. Maybe it makes my numbers a little bit smaller. And let's see if we can factor this one in orange. That'll make my life easier. So in orange, a times c is 12, right? So again, I'm just focusing on the orange here. B value is 8. I get two numbers that multiply are 6 and 2. 6 times 2 is 12. 6 plus 2 is 8. So 6, 2. That gives me x plus 6, x plus 2. And we have this 2 on the outside. So I still have that 2. And we're just trying to find the zeros, or where it crosses the x-axis. So actually, I don't need that. That's it. We can just set each of these equal to 0. It's just an arrow. X plus 2 equals 0. So then you will get x equals -6 and x equals -2. So those are where it crosses our graph. -6. 1, 2, 3, 4, 5, 6, and -2. And this graph, do we pick a color? Let's do pink. Pink. Okay, it has a y-intercept of 24. So something way up here. And it's positive, so the graph's going to go up. So the graph's going to look something like this. Okay, so I know it's going to go through that graph twice. I mean, we're supposed to go through that green. And here's an art lesson. If the points you have don't exactly look like, you can always thicken the graph, because it has to go through that orange and the green dots there. 2 solutions. See you guys.
Love math. You don't love math? What's wrong with you? I love math.
Hey guys, let's go over D for solve the systems of quadratic equations and verify algebraically. So I got these right here. And what does substitution basically mean? First thing we're going to do is we're going to solve by substitution. Every time I see y, we're going to write 3x plus 1. I see a y here. Instead of writing y, we're going to write 3x plus 1. And then this right side is the same thing. But because they're both equal to y, you're setting them basically equal to each other. And what we're going to do here is we're just going to solve. So I'm going to move this 3x to the other side. I have to use the opposite. And this one subtract 1. So we're going to get 0, 0, negative x squared plus 3x minus 7. Okay, remember here you can use the discriminant to check how many solutions you're going to get. So the discriminant is b squared minus 4ac. And my a is -1, b is 3, and c is -7. Okay, so let's just put that in and then see what we get. It's going to equal something, inequality. So b is 3, a value is -1, and c value is -7. So I get 9, -4 times -1 is positive 4, 4 times 7 is -28. So you get some kind of negative number. -19, what do we know about that? That is less than 0. Okay, what does this mean for us? This means we're going to have no real solutions. And all that basically means is it's not going to touch, not touch. There's no intersections, no intersections. Okay? This is good for us. Why is this good for us? Because watch, I can actually just graph this and see that they're not going to intersect. Here is my x, my y coordinate. Let's graph the. Here I again have slope-intercept form. My y-intercept of 1, and then remember slope. Alright, so we're graphing this y equals 3x plus 1. The slope is 3. Remember, you can just make that a fraction by putting it over 1. And so basically what you have is a rise of 3 and a run of 1. So that means up 3, right 1. That's how you graph a linear equation. So let's go ahead and do that. So up 3, 1, 2, 3, right 1. Right, up 3, right 1. Okay, and that is my graph. Let's do our best. And let's go ahead and graph and turn off the, because we want to see how I invert the colors. So I go here, accessibility display, and turn off the colors. Did that change it? Alright, let's see. And then how do you graph this next one here? Okay, so this is in standard form. A couple of things you should notice. You should have a y-intercept of -6. 1, 2, 3, 4, 5, 6. There's my y-intercept, -6. And then it has an a value that's negative. Okay, so how do I show that these graphs do not intersect? Could look something like this. Again, we said the discriminant, when we did the substitutions, my battery is still working on it, but that we had a discriminant when we combined those two equations that was less than 0, so that means that the graphs don't intersect. Now, how do you know that this graph doesn't touch the x-axis? You can also use the discriminant there. And then this problem, I actually want to show you guys by using the graphing calculator. So I'm going to pull this up. Let's go ahead and input here. So click on y equals. We have negative x squared plus 6x. And when you're using the variable button, that's the top left near the alpha second, not sometimes the letters on the keyboard, -6. And then for the second equation, we have 3x plus 1. And you're going to press graph. We have a zoom button. Let's just get graph. Okay, so here's my graph, and I can zoom in. You can see that it's changing the axes. And you can just see that they're not going to intersect.
Love math. You don't love math? What's wrong?
Hello, let's go over D5. Maybe you always ask, why do I use the black background? Because you stare at a white screen, my eyes hurt. So that's the reason. So we're going to solve this quadratic systems here. And I like to draw this down the equal sign. And we're going to do it by substitution. Why? Because they both have y equals. So we'll use a highlighter. Every time we see y, we're going to write -6x minus 6. Here is a y variable. But instead of writing y, we're going to write -x plus 6. Let's write that. Let's do that. -6x minus 6. And everything on this side stays the same. Okay, using your steps, now we're going to set equal to 0. So I'm going to move this negative 6x. I'm going to use the opposite. And move this negative 6 to the opposite, positive 6. Okay. This gives us, this will equal 0 and 0. This one falls down, 4x squared plus 12x plus 9. Okay, how do you solve this quadratic equation? So we're hoping we can do something called factoring. So let's try to factor this. A times c, my b value, so a times c is 4 times 9 is 36. And my b value is 12. Goes to all the combinations, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Any of those work. Right there. Okay, pay attention now. A value is greater than 1, so you're going to have to do both the x and the y's. So there in blue, I get 6x and 6x, okay? The a value always goes in the top left. The c value always goes in the bottom right, always. And now what we're trying to do is find the greatest common factor going in this direction. That's going to be a 2x. This direction, a 3. This direction, 2x. And this direction, a 3. So we're going to get 2x plus 3 and 2x plus 3. Now, I should have done the discriminant, which I didn't in this problem, but hopefully you can kind of guess or see why that it's going to be a one solution. Why? Remember the discriminant, b squared minus 4ac. It's after you've combined the equations through substitution. My b value is 12. My a value is 4, and my c value is 9. So we're trying to think about how is this in relation to 0. And what the discriminant will tell us how many solutions. So 144, negative 36 times 9 gives me negative 324. And if you add that to 144, I'm going to get negative 180. Negative 180 is less than 0, so we're going to have no real solutions. What does that mean? Graphs will not intersect. Graphs won't intersect. Okay? What does that tell us? Okay? This tells us that even though, let's just say that you kept going. Okay, we already know this information. But let's just keep going and see what happens, okay? You set these equal to 0. It's the same thing. Do it once, you've already done it. 2x equals negative 3. X equals negative 3 halves. So you get x equals negative 3 halves twice. Now, if I stick negative 3 halves into that equation, I'm going to write this one again down here. Let's do it. Let's do that right after the highlighter. Do you guys do that? Y equals negative 6x minus 6. And I'm trying to find the y coordinate, so I just have to stick in one of these. Fractions. Y equals negative 6. Instead of writing x, we're writing negative 3 halves minus 6. Okay, so how do you deal with fractions? Negative, I'm going to put this as negative 6, okay? 6 is 2 times 3, and you have this negative 3 over 2 minus 6. Okay, so what am I going to do is I can cross cancel, right? See these 2's? Gone. Okay? Why can you do that? Because it's by multiplication. 2 divided by 2 is 1. So I'm left with negative 9 minus 6. Negative 18 divided by 2. Negative times a negative is a positive. So, why do I get a 3? Let's take a look. These 144, 4 AC. Did I multiply my numbers wrong? 16 times 9. Over here. I knew it. I was like, how did I get a number over here? So that's wrong. That should have been 144. So that gives you 0. So that was wrong. And what does it mean that it is 0? Well, if the numbers are equal to 0, that means you're going to have one solution. And we have the one solution because it just appears once. Okay. So what does that mean that y equals 3? So if you have the x and the y, you have an order pair that's -3/2, comma, 3. This is the point of intersection. Okay, let's go ahead and graph this and we'll see that. Let's graph -3/2. Okay, we said that was -1.5, comma 3. -1.5. -1.5 up 3. There it is. Okay, let's mark it. This is where the worlds will collide. Okay, let's see. Y equals -6x minus 6. So again, mx plus b, it's linear. My y-intercept of -6, 3, 4, 5, 6. Okay, and it has a slope of -6 over 1, which basically means down 6, right 1. Does that say down? That says down. Okay, let's try it. Down 6, 1, 2, 3, 4, 5, 6, right 1. Okay. Now, you can do the opposite. This is crazy. Watch this. You can also do 6 over -1. Why? Because a positive divided by negative is negative. So this would be up 6 to the left 1. Let's try that. Up 6, and you'll notice it falls in line. Up 6, 1, 2, 3, 4, 5, 6. Left 1. See it? Let's just do it one more time. You don't need to, but this is fun. Left, up 6, 3, 6, left 1. Okay, and you can kind of see why we're going to that red line. So that was a green. That was a green one. Okay, so let's do our best. Okay. Wada. There you go. Great. All right, let's do the red one. Okay, standard form. And what does standard form tell us? That, okay, C value of 3, right here. Okay, A is positive, so it's gonna go up through this point. Let's see if we get super accurate. You can factor this. It may not work, but I'm going to try it really quickly so I get a really accurate graph, and I'll show you guys digitally. A times C is 12, B value is 6, two numbers that multiply to be 6, or 12, that add 3, 4, 2, 6. None of them work. Okay, so it's not factorable. Okay, so I have to go through, my graph is opening up, and it has to go through the intercept. Huh, this is going to be a fun graph. And I have to go through the red and that orange. Maybe the graph is like this? I don't know. That's my best guess. That's the 1 point of intersection. Okay, let's use technology. So, show you guys what I use this one called Graph and Calc 83. Graph and Calc 83. And then you're going to type in your two equations. So I have 4, here's my cheater, xx right above apps, that's x squared, plus 6x plus 3. And this is a free app. So the negative in subtraction signs is where usually students make a mistake. So negative 6x minus 6 is on the right, okay? And then you're going to press graph. And there's our graph. It's kind of not fun. Let's see. It's pretty cool. Didn't have 2 different colors, but your intersection's only going to happen once through there. For high level math, that's called a tangent when the graph intersects at one place like that. Okay? Does that look like ours? See you guys. Hey guys, let's go over D6, solving this quadratic systems. I got y equals 4x plus 1, I equals 3x squared plus 24x plus 50. Alright, what am I going to do first? The first thing I'm going to do is do my substitution. How can I do the substitution? They're both equal to y. Let me show you guys in a different way. I'm just trying to show you guys multiple representations here. If you write this thing over here, you're going to have something that looks like this. 4x plus y, 1 equals y, right? See that? And then you don't technically need the y variable. So you're going to have 4x plus 1 equals all that. Okay. Now we need to set it equal to 0. So we need to basically move everything away. So I'm going to use opposites to go across the equal sign. The inverse math operation to go across the equal sign. Why is that the case? Because it equals 0. 4x minus 4x equals 0. 1 minus 1 equals 0. Then I'm left with 3x squared plus 20x plus 49. Okay. Now at this time you can deploy the discriminant. And what the discriminant tells us is how many solutions there are going to be. B squared minus 4ac, and then you're going to put an inequality in this box. Okay, let's do that together. It's like purple. B is 20. 4, A is 3, and C is 49. I think it's going to be some kind of huge number. So just punch in your calculator. Got my handy dandy calculator right here. 20 squared gives me 400. Okay. 400, and then negative 4 times 3 is negative 12 times 49 gives me negative 588. And if you add those together, that's negative 188. So what can I put in this box as an inequality? Negative 188 is less than 0. Okay, why is it important to do the discriminant? Okay, because you would have gone on forever to work on that equation to solve it, and then solve an x and get a y and get an order pairing graph. Okay, it's basically telling us that the graphs won't intersect, and it basically tells you to stop. Now, I know students who are going to be kind of lazy and just say, okay, I could just say that for every single graph. You got to check the discriminant. All right, let's graph this thing. Let's go ahead and graph the linear first. Super easy. the mx plus b, right? B is the y-intercept of 1, and then a slope of 4. Remember, slope is rise of 4 and a run of 1. What does that mean? Up 4, right 1. Okay, let's do that from the y-intercept. Up 4, 1, 2, 3, 4, right 1. Boom, that's a point. You can do it all day long. Right, 1, 2, 3, 4, right 1. And so we said that was green, so let's go green. Ready? Okay, here's my linear graph. Okay? Alright, let's try a more difficult one now. Let's choose, I don't know, purple. Have I done purple? We're going to make it a purple graph. But to work with this purple graph, you have a standard form in quadratics, no parentheses, right? And here is my y-intercept. Okay, let's think about this. Y-intercept of 50, my graph only has, I'm assuming, 10. So it's like way off the page, like way up there, okay? Way higher than the page, and then it goes up, it's an A value, so it's going graphed up. So how do I reconcile this graph, okay? I don't know, I'm just drawing this graph. What is it, purple, right? Highlighter purple, okay? I don't know, something like this. Does the graph ever intersect here? Do the purple and the green over here intersect? No. And that's what we said way down here with the discriminant, right? So let's prove that and use our graphing calculator, okay? So let me show you guys a graphing calculator I'm using. I'm using the one here on the right called Graph, G-R-A-F, in Calc 83. I just checked today, it is free. And what it is a, looks like a regular graphing calculator, okay? And let me find it. I forgot what problem we're doing. Okay, so go to y equals in the top left, okay? Use the up and down arrows, and you're just going to press the word clear. You can use Desmos too. So 3, and then here's my trick for x squared. It's x. There's actually multiple places where it says x. X on the far right is the math operations in blue, so don't touch that. It's the one to the top left next to alpha. Now there's also an x. I think I see... no, I don't. So just use that one. Use it twice, because x times x is x squared. Plus 24x plus 50. And I changed it to be green. And if you go down, you can just click on that and change it to whatever color you want. So I just picked a different color that's super obvious. And it's kind of cool because you can see the inequalities in different colors. Alright, I got 4x plus 1. And then you're going to press graph. Now, in a regular calculator, a graphing calculator is in the top right, but this one is in above mode. So you just press graph, okay? And there's my graph. Does that kind of look like ours, right? The intersection of 50 up here, right? That was the y-intercept, and the graphs won't intersect. We saw that based off of the discriminant, okay? See you guys.
We love math, we love math, we love math, every time we divide, we already know the path, Then we multiply, all we gotta do is roll the die,